Welcome. Today we're going to discuss the iTwin Analytical Synchronizer. Bentley's Integrated Structural Modeling, or ISM, is a technology for sharing structural engineering project information among structural modeling, analysis, design, drafting, and detailing applications. ISM is similar to Building Information Modeling, or BIM, but focuses on the information that is important in the design, construction, and modification of the load-bearing components of buildings, bridges, and other structures. There are two main purposes for utilizing ISM in your workflow. The first is to transfer structural information between applications, and the next is to coordinate the structural information between two different applications. In this particular video, we're going to show you how to use the iTwin Analytical Synchronizer for viewing and revising an ISM repository that was supplied to you from another application. Now, the iTwin Analytical Synchronizer serves several different purposes. You can open ISM repositories for viewing, navigating, and querying the model. When opening an ISM repository with the iTwin Analytical Synchronizer, the most recent history point of the repository will be opened. You can also review and manage all history points of the repository. Different revision points can be compared, merged, or deleted into a single ISM repository using the Design History tool. You can also make some limited modifications to the ISM repository, including adjusting your node alignments and doing general model cleanup. And then lastly, the change management feature and the iTwin Analytical Synchronizer are launched when creating or updating either an ISM repository or a client application model. This will allow you to accept or reject changes for consensus data in the repository. So let's go ahead and turn our attention to the desktop, and I'm going to launch the iTwin Analytical Synchronizer, and I'm going to open up the ISM repository that was just supplied to me by my architect. Once in the iTwin Analytical Synchronizer, I can go ahead and open up the ISM file. Here you can see I've already saved it in my recent files area. So let's go ahead and quickly discuss what we have thus far in the overall workflow of our project. So for this particular project, I, along with the architect and mechanical engineer and the draftsperson, are working together to create a station model for a bus terminal. This model actually contains two structures. You can see here I have a wooden trellised structure supported by steel columns, and then I also have a very unique framing system for the actual bus terminal. Now, what we've decided for this particular project is that the architect was going to go ahead and get started on their BIM model, and for this particular exercise they went ahead and used Open Building Designer. They've created all the main structural geometry and then sent it over to me for structural analysis and design. Throughout my workflow, my plan is to go ahead and bring this into the appropriate engineering applications, either STAAD.Pro or RAM elements for this particular scenario, and then complete the design. Now, before I do any of that, what I like to do is take a look at the ISM repository, specifically if I am not the one that created the initial BIM model, so I can review the information that is contained within, and it'll give me a good chance to let the architect know if everything is modeled correctly for my purposes, or if maybe it would make more sense to tweak the model a bit in the BIM application. So let's go ahead and start by taking a look at the model. Now, at the top of your screen, you're going to go ahead and see the ribbon toolbar in the iTwin Analytical Synchronizer. From here, you can go ahead and adjust your view of your model. You can adjust your units and tell the program what you want to go ahead and view on your screen. In addition to that, if I select the Tools tab, we do have a few tools that we can use to audit the nodes in this particular model. Now, the way I'm going to start with this particular model is I'm going to take a look at the objects that were brought in from the BIM application. The main structural elements will be either indicated as surface elements or curved members. Curved members being any linear member like a beam, a column, or a brace. So let's go ahead and expand each of those areas. Now, as I take a look here, I can select any member over here and I'll go ahead and highlight it in the main window. I can see the information that was assigned to it. Here I can see the section properties, and I can see if a story or any other information was assigned to it. Now, as I go through, I can select each individual members either in the table, or I can also click on them on the main screen. Now that I've selected a particular member, I'm going to go ahead and take a look at some of the properties that are assigned to this member, and these properties were assigned in the BIM application for this example. So I'm taking a look. I can see the name has been assigned. This will be the section properties. Now, for this particular model, the majority of the sections were assigned using the AISC standard sections database. That being said, when I import this model into either STAAD.Pro or RAM elements, I should be able to see that the appropriate section properties were assigned through the databases that are installed with those particular programs. Now, let's go ahead, and I've selected a typical steel member, and this model also contains some wood members. Here you can see that this was given a different type of name, and this is more of a prismatic section property. So if it is a steel member with a corresponding shape within the database installed with each program, you should be able to import it successfully. Otherwise, the program will go ahead and attempt to import it as a prismatic section. The other thing I like to point out is this field here, this load resistance field. Now, it's very important that the load resistance field is not empty. If the load resistance field is empty for any of your curved members, they may not import into your structural application. The reason for this is because we would use this field to indicate when there are architectural members in your ISM repository that don't necessarily belong in your structural application. An example for that might be these wooden members that we can see here. And these are basically wrapping the steel structure beneath. These are wood members, and you can see here that this load resistance field was set to none. I went ahead and coordinated this with the architect, as these types of members won't be designed in STAAD.Pro, but the steel column within that wrapping will. The last thing I want to point out is for this particular model, I've gone ahead and worked with the architect to assign the appropriate material properties to each of the steel type sections within this model. Here you can see that I have a tube section, and I asked them to go ahead and assign the ASTM A500 grade B material to all of the tube sections in the model. I have other types of sections in the model as well. You can see here I have a wide flange column, and again I asked them to assign the appropriate material properties to those columns. Now, that being said, do I have to take a look at these material properties once I get into STAAD? Yes, I do, because although they were given different material classifications, I still want to make sure other pieces of information such as modulus of elasticity and yield strength of steel are appropriate, and that type of information might not be contained in your BIM model. So I'm going to take a special look at things like sections and material properties once they come in. Now that I've gone ahead and reviewed the curved members in my model, let's go ahead and go back to see everything. To return to your previous view, if you had selected a particular type of member, you can just click on this Home button here. This will reset this table. So we've gone over our curved members. These are your main structural members, beams, columns, braces, for example. In addition to that, we also have our surface members. These would be any type of plate elements that were created in your model. For this particular model, I have my main plate elements that are going to basically be in the surface of the roof system. I've gone ahead and asked the architect to assign the appropriate material properties and what we're assuming is going to be the plate thickness for these particular members. Now, in addition to that, for architectural reasons, they also created several other different types of plate elements within this particular model. So here we can see, if I scroll on up, that things like base plates and little bracket systems have been added in this model. So what I'm going to do is, as I'm working with the architect, I'm going to have a very good understanding about what pieces of information belong in my STAAD.Pro model and what pieces of information I'm maybe not necessarily interested in bringing over. For example, I plan on designing my base plates eventually with RAM connection. I'm not going to bring in the base plates from this particular BIM model. So I'm going to review it from those types of aspects. So now that we've gone over our main structural system, our surface members and our curved members, there's several other sections of objects that have been brought in. Anything that's under a material property, here I can see I have a folder for concrete and a folder for steel. What this will do is it'll tell STAAD.Pro or any other structural application that's linked with the ISM process to bring in these types of material properties into the model that I'm eventually going to be bringing in. Now I can see here I did work with the architect to make sure that the appropriate material properties were assigned to each individual different types of sections within the model. I can see up here I do have some areas where I'm not exactly certain what happened here, so I'm going to take a little special look at some of the material properties as they come into STAAD.Pro, and I'll make that decision if I should be making those adjustments in STAAD.Pro or going back working with the architect and seeing if we should adjust the BIM model instead. The last thing we're going to take a look at is we are going to take a look at our table section information and also our parametric sections. Again, this will be the information that'll tell the program, specifically STAAD.Pro in our example, of what sections to create in the properties dialog once we get in there. So here we can see that these are all the prismatic sections. These are all the standard AISC sections. Now, if you remember to bring in a member, but not its section property, what the program will go ahead and do is it'll bring in the member, but it won't be assigned a section property once you get in there. So that'll be a choice that you'll make upon import. So now that I've reviewed the information that was supplied to me through this ISM repository from the architect, there's one more thing that I also want to take a look at. And I'm specifically going to take a look at the analytical model, and I'm looking for things like connectivity of members. So let me go ahead and show you how I would do that. What I'm going to do is I'm going to go to this levels area, and I'm going to decide what type of model I want to take a look at. And I'm going to take a look at the stick model here. This will give me a good two-dimensional approach about what's contained in this ISM repository. And I'm going to take a look and see how everything's kind of shaking out. In addition to that, if I wanted to see my nodal locations, I can turn those on by auditing the nodes in the model. So if I went to the Tools tab in the ribbon toolbar and told the program I wanted to audit the nodes, it will go ahead and generate where the nodes in the analytical application will be placed most likely and give me an opportunity again to review the connectivity of my model. So let's go ahead and click OK. We are allowing iTwin Analytical Synchronizer to generate your nodal locations. And I'm going to go ahead and take a look at that again in the analytical view. To grab the analytical view, I'll go ahead and click Select All, then Accept, and then I'm going to click on the Preview button. The Preview button will allow you to see, before you officially make those changes, to see where everything's going to be located. Now I can see in purple all of the nodes that would be created with this model, more than likely when it's imported into a structural application. Okay, but what I want to do is specifically I want to view this again on the analysis model. So I'm going to go ahead and select the analysis model, and then I'm going to take a closer look. Now again, this particular model has extra steel pieces that I'm not going to necessarily bring into STAAD.Pro, so I'm going to not give those much attention as of yet. You can see here I have some steel plate brackets, some base plates, for example, and so forth. I also have those architectural wooden members that are kind of wrapping my structural steel. What I am looking for, however, is I want to make sure that, say there's a girder member that's supporting a beam, that those are drawn in the same plane, that their analytical lines are intersecting at a common node location. And this is where, if you are planning on starting a model with the BIM model, you will need to work with your architect very closely. It's important that your analytical member lines in your BIM application do intersect to make sure that there is proper connectivity. Here you can see I have my wooden girders. They are supporting my wooden beams. They are all drawn in the same plane. So now when I import this physical model into STAAD.Pro, I know that everything's going to be properly supported. Now, one area that I am seeing that I may want to work a little closer with my architect on is these particular columns right here. Now, as you can see, these columns were drawn to the bottom of the wood girders, but the wood girders were given a placement point of top center. Okay, and what we're going to notice is that the analytical line that represents the column is not going all the way up to support the wood girder in this analytical model view. So what are my options here in a scenario such as this one? Well, if it was an easy change in STAAD.Pro, I might consider I'm just going to go into STAAD.Pro, make some changes. I could either move this node on up once I get into STAAD.Pro, that might help me. I could create a control-dependent relationship between these two nodes to make sure that force is being transferred from the girder down to the column. Or lastly, I can go and work with my architect and ask them to maybe adjust some of their placement points to ensure that those analytical members are intersecting each other. Now, since it's just the columns, I'm not seeing any other glaring information of where I might need to make those changes. I'm going to go ahead and leave it as is and attempt to make those adjustments once I get this model into my structural application. Now, I don't need to actually bring these nodes into my STAAD.Pro model, so I'm going to go ahead and click the Cancel button. So I'm not interested in bringing those nodes. I've just used that tool to interrogate my model to see if there's anything that I want to work a little closer with my architect on, or anything that I'm going to need to pay special attention to once I get this model into STAAD.Pro, which is an excellent use for the iTwin Analytical Synchronizer, taking a look at what you've received and kind of understanding how it's going to go into your structural application.